how to make a full-fledged Rubik's Cube game with a 3D cube, time counting, rotation generation, and with the output of a message about the victory when the Rubik's Cube is assembled. To implement this, we will use HTML, CSS, JavaScript, and Three.js. Let's create index.html, styles.css files, and Rubik's Cube.js file to implement the logic. Include a button element that will initiate the game. Insert a canvas element where the Rubik's Cube will be rendered. Create a div to display the game timer. Include a div to display the game instructions. Create a div to display a congratulatory message where the player solves the Rubik's Cube along with the restart button. Add the Three.js library and the orbit controls script essential for rendering the 3D Rubik's Cube. Link the JavaScript file containing the game logic. First, create the styles for the body element to center all content and set a background color. Display flex enables flexbox layout. Flex direction column. Arrange the child elements in a column. Next, create the styles for the buttons to have padding, font size, margin, background color, text color, border radius, and the hover effect. Border radius 5 pixels, rounds the corners. Cursor pointer, change the cursor to a pointer on hover. Transition background color, add the smooth transition for the background color change. Create the canvas styles. Display none, hide the canvas element. Position the timer at the top left corner with a semi-transparent background, padding, border radius, and box shadow. Position the instructions below the timer with similar styling, including a max width to ensure it doesn't stretch too wide. Max width 200 pixels, set the maximum width. Create the winner message styles. Initially hide the winner message and position it in the center of the screen with a semi-transparent background, padding, border radius, text alignment, font size, and box shadow. Create the button inside the win message styles. Add margin to the button inside the win message to separate it from the text. Create utility classes to toggle the visibility of elements. Now let's move on to implementing the logic in the JavaScript file. First, add an event listener to the start button. When the button is clicked, the initialize cube function is called. Create the initialize cube function, which will handle the initialization of the Rubik's cube. Create a hidden start button. Display the canvas where the Rubik's cube will be rendered. Display the timer. Then display the instructions. Create a new Three.js scene. An aspect ratio based on the window size. Create a new perspective camera with a field of view of 75 degrees and near and far clipping planes at 0.1 and 1000 units respectively. After that, create a new WebGL render and link it to the canvas element. Set the size of the render to match the window size. Set the size of the cube and the size of each cubelet. Define an array of hexadecimal color values for the cubelets. Loop through each position. Create a new box geometry for each cubelet. Create an array of mesh basic material objects, each with a different color. Then create a new mesh for each cubelet using the geometry and materials. Set the position of each cubelet in the grid. Add the cubelet to the cubelets array. Then add the cubelet to the scene. Set the camera position to view the cube from a distance. Add orbit controls to allow the user to rotate and zoom the camera. Create a new 3.vector3 to represent the rotation axis. Set the appropriate axis to 1. And then create a rotation matrix. Apply the rotation matrix to the kubelet. Loop through each kubelet and check if its position along the specified axis matches the layer. Round the kubelet's position to ensure it stays aligned to the grid. Define eraser for the possible axes, layers, and directions of rotation. Loop 20 times to perform a series of random rotations. Randomly select an axis, layer, and directions for each rotation. Call the rotate side function with the selected axis, layer, and direction. Call the random rotations function to scramble the cube. Define the animate function. Request the next animation frame to create a continuous loop. Update the orbit controls to handle user interactions. Render the scene with the camera. Check if the Rubik's cube is solved. Start the animation loop. Add an event listener for the key down event. Use the switch statement to handle different key presses. Call the rotate side function with the appropriate axis, layer, and direction based on the key pressed. Check if the Rubik's Cube is solved after each key press. Add an event listener for the resize event. Update the camera's aspect ratio based on the new window size. Update the camera's projection matrix. Set the size of the render to match the new window size. Initialize the start time variable with the current time. Set an interval to call the update timer function every second. Define the update timer function. Get the current time. Calculate the elapsed time since the game started. Calculate the number of minutes and seconds from the elapsed time. Update the timer display with the formatted minutes and seconds. Define the check if solved function. Define an array of solved colors for each face of the Rubik's Cube. Flatten the array of cubelets to get the current colors of all cubelets. Loop through each face of the Rubik's Cube and check if the current colors match the solved colors. If all faces match, call the showWinMessage function. Define the showWinMessage function. Clear the time interval to stop the timer. Display the win message. Add an event listener to the restart button to call the restart game function when clicked. Define the restart game function. Hide the win message. Reset the timer display. Update the start time to the current time. Set a new interval to update the timer every second. Clear the scene on Kubelet's array. Reinitialize the Rubik's cube by calling the Initialize cube function. As a result, we created a full-fledged Rubik's cube game with a 3D cube, time counting, rotation generation, and with the output of a message about the victory when the Rubik's cube is assembled.